All right, so, okay, let's see. Did anybody have anything specific this week that you wanted addressed before I jump into the one item that I have? Bob, anything exciting happening up in Chicago area?
Well, I can tell you, I got my shot yesterday, my vaccine shot. The interesting point was, and I've talked to my friends, after a year of being locked up in this house and worried about catching this thing, and then having the carrot go out there that the vaccine is coming, and then living in Illinois where the vaccine is not coming, emotionally has caused me literally to, my anxieties to go to heights that I never thought I would ever experience. And I confide to some friends and they're going exactly the same thing. And ready for this, the thing that makes it worse is that when your friends start getting the shots and you don't, you got to be nice to them and say, I'm happy for you. And then I go, what the heck's going on? Why is everybody getting it and not me? What did I do wrong, you know? And it is just, so I went in yesterday and I was shaking. And after I got the shot, I totally crashed emotionally.
Really?
So
yeah, I've kind of been of the mindset of I'm in no hurry. I'll let whoever ahead of me wants to do it until there's more supply than demand. That's kind of been my attitude. Then I'll go ahead and do it because I'm fine to be away from people. Just as soon not interact. So,
well,
you know,
I'm out in a busy area here and I've lost 2 friends to the COVID-19 now.
Yeah.
So it makes it very real. In fact, one of the women who lost it was given to her by her children.
Yeah.
So go figure that one out.
Well, one of the issues that I guess I'm just a little bit concerned because next week I'm teaching a class here at the college and it's going to be 8 hours a day, 6 days in a row, interacting with 19 students. So that is a risk, but you know, we'll mitigate it as best we can. So
could you describe the class?
It's a small wind certification class. So we're going to be teaching about how to design and install small wind systems. And then on Saturday, a week from Saturday, the class will go out to our farm and we have a 30-foot wind tower. And one of the labs is you have to lower the tower down, do maintenance, and then raise the tower back up. So that's an interesting little lab. But the wind class
in the Columbus area?
It's in Zanesville. So it's like halfway between Columbus and Pennsylvania. You know, if you just go right along I-70. So.
What, an hour drive?
Yeah, about an hour drive from Columbus. Okay. Yeah.
Well, that's the second reason for me to come up there.
Okay. All right. Well, we'll get you there at some point. In fact, we've got an intern lined up for this summer who's going to work. We've got a tiny house project and she's going to work on the tiny house. And one of the reason I've got the wind turbine is it's there for the tiny house. So we're going to hook up a small standalone array with a small wind turbine and the tiny house will be completely off grid. And we just wanted to play around with that. The idea is maybe someday we'll have a farm manager who decides to live there and they'll have their own little building. So it's a cool little house, but it's been such a low priority that, you know, it's contained enough that it's not going to fall apart. You know, it's weatherproof, but that's about it. So that's our chore. That's our goal for this summer anyway. Then I've got another project that I hope another intern's going to work on where we're going to convert a golf cart into a solar, generator, a mobile solar generator, but then also set it up so that I can hook it into our home as an emergency power backup system. So
So you say you're going to put solar on a golf cart that electric golf cart, I assume,
yeah,
that has batteries
yeah,
and vehicle to grid is what it's called, right?
yeah, it will be a V2G kind of system
To a house. Yeah.
to our house, but we'll have to do it in such a way, I think, that I've got to physically turn off the main before I hook in, because it will not have an automated
sync.
transfer switch,
Yeah.
you know, for that. But I could just get a generator transfer switch and then have the hook-in location at the generator port. That would work all right.
You know,
So-
I recently got a three-wheel bicycle with a hub motor. And I was toying with the idea of putting some solar on the top, but the hub motor is it's a 48-volt system, and finding lightweight flexible panels, they cost a premium.
Yeah.
You know, unfortunately, because they're not as common as MPPT, or at least 48-volt panels and what have you. It's unfortunate.
Yeah, I was looking, because of the golf cart, it has a rigid canopy. So I could just hook up two 24-volt standard, you know, silicon solar panels, mount them on the canopy, and then you'd have a 48-volt system.
But they are heavy.
Yeah, but the canopy of the panels, I mean, each of those panels weighs about 50 pounds. So it's only 100 pounds distributed over a fairly large surface.
Sure.
You know, so for a rigid canopy on a golf cart, it's not going to be a problem. But if you wanted it to look good, you know, be stylish, that might be a problem. But yeah, the other issue that I've run into is when I was researching golf carts, some of them are 36-volt systems. So that's something I'll have to look at, is make sure that whatever I get is 48-volt, because they really don't make any 18-volt panels that I could hook up, you know, for that. Most of the commercial 60-cell panels are either going to be 20-volt or 24-volt panels. So nominal voltage. So. All right. Anybody have any news or any issues before I jump into the yeah, Bob?
This is a bit off the subject, but I have a friend who put his freezer out in his garage in Chicago.
Uh-huh.
And it gets down to 18 below. How does that work?
Well, then, yeah, your freezer basically becomes almost an insulator to keep your food warm. So, but it shouldn't, I mean, it should work just fine, really. Are you worried about the electricity, or are you worried about the food?
I'm having a hard time with the thermodynamics of the deal, because
Yeah.
you're taking heat out of the freezer and putting it into the air.
Yeah, it is a little bit. But really, your freezer shouldn't be operating when the outside temperature is that cold, because it's got a thermostat on it, and it only runs when the inside temperature, you know, drops or raises above a certain set point. So if you're in an environment outside that's colder than that set point, there's be no reason for the food or the inside to heat up. In fact, the insulation will probably keep it warmer inside the freezer than outside.
So that would work. Okay.
Yeah, you wouldn't be running. Yeah, we keep both of our chest freezers up in our garage, and the same thing. They just, if they were kicking out heat, they'd be kicking it out to the atmosphere. But in the wintertime, they hardly run at all. So that's good.
Okay.
Yep.
I'm going to be doing that.
Yeah, no, that makes sense. Although you'll be in Florida, so you know, it'll always be warm.
I have a place up here for you guys to visit, and a place down there for you guys to visit.
You could move to Texas, then you don't have to worry about the cold, you know.
Who would ever live in Texas?
It's hard to imagine. So.
I can't imagine.
All right. Well, before we touch on anything specific, I want to jump in. I did have a request from someone regarding the Iron Ridge roof-mounted system. So I'm going to jump in and take a look at that. So in the online course, there's this particular quiz here. It's on using the Iron Ridge mounted design tool. So I think you need to log in here. So we've got to log in, and let's say, I don't know, let's pick on somebody's house. Bob, you want us to use your house?
Sure. 60070. Mount Prospect Heights. You want my address?
Is it Prospect Heights, Illinois?
Yes, yes.
Yeah. So then this system, this is the Iron Ridge system here. And the first thing it's going to do, not quite sure what it's doing there. I guess I got to confirm that this is the location, accept the terms of service. So then it's going to ask us a certain number of questions on how you would design your system. Now it's already plugged in based on your location. Some of the codes like snow loading per square foot, they factored in 25 pounds. Wind speed, 115 pounds. You're in a wind exposure category B, risk category 2. So this is all populated into the system based on your zip code. Then we would select a panel. So just pick one. Let's pick a CSUN panel. And let's just randomly pick a 340 volt CSUN. So this is just if you're designing your system, it's got the stoppers, the sleeves. Those are basically how you mount it in. You can make whatever project notes. I'm gonna move this, trying to see. There should be, I should be able to move forward. Pitched roof. Okay, I'm gonna save that. Yeah, then it's asking me composite shingles. So even if your house doesn't have shingles, let's assume it has shingles. And we're going to use the 4-inch flush to roof mounted standoff. We don't need the mounts. The building height, is it a single story?
Yes.
I'll just say up to 20 feet. That should be fine. Then we'd have to know your roof slope. Do you happen to know it offhand?
22 degree.
22 degrees?
Sure.
And do you know what the rafter spacing is?
16 inch.
16 inch? All right, so we'll save that information. And then it's going to ask us, this is telling us, I haven't used this in a while, so I guess if we wanted to go with graphical, we would take this and let's assume that we're just going to put in we'll do 3 rows of 10. All right. I think I should have hit crop. All right, so now it's going to ask us, it's going to tell us what kind of materials we're going to need. We've got 30 modules, portrait orientation, tells us the total weight. The square foot, the distributed weight is only 2.6 pounds per square foot. And the rails, So this is telling me I need this much length. I need 18 attachments, 2 splices, 22 clamps, and oh, it's asking me for the portrait type. I'm going to go with the XR 1000. It says the maximum cantilever. So it's saying that I could have a span of 9.2 inches between my supports, which doesn't sound right to me. The maximum cantilever, that would be the where you have your last support. It could extend another 3 feet beyond that, you know, before you have that mount, you know. But what I try and do is cantilever as little as possible. So I'm trying to think that if we've got 18 attachments, you've basically got 6 rows of rails, right? Is everybody conceptualizing that? Because if we look at our panels here, we're going to have a rail here and a rail here, and then a rail here and a rail here, and then another rail here and another rail there. So it's going to be 6 rows. The length looks like it's going to be 32 feet. Does that make sense? 32 feet long, 3211. Well, each of these panels is about 3 feet wide. So that makes sense, right? It's going to be 32 feet long. And they're saying here that you really only need a support every 9 feet. Boy, that seems too far apart for me.
And those rails are the heavy duty rails you picked.
Yeah.
So
Yeah,
those
if I-
those are huge rails. I always use the one on the intermediate, the 100.
The 100?
Yeah, and now it goes down to 7.3.
Yeah, 7 feet. But really what I've normally done is with a 16-inch, basically with a 2 foot, I go every 4 feet with my supports. You know, skip every other rafter for your support. That might be overkill, but I just feel like it's a better design. This is showing us that we have a maximum span. You were in a zone 2, is that right?
Yeah.
Risk category 2?
By the way, when I called up these guys and asked them what that information was all about, they had no idea.
They didn't know what a zone 2 was?
They didn't. That was done by some engineer into the software somehow.
Isn't the zone the location on the roof, whether it's an edge or
Yeah,
something like that?
yeah, you're right. Zone 3 is in the corner, zone 2 is on the edge, and zone 1 is in the middle. Yep. So I'm assuming we're putting it in zone 1. That's where you want these things to be. So zone 1 is where we're going to be. And 7'3". So what does that mean on a 16-inch center? How many can you skip? So that would be 7 times 12. That'd be 84, 87 inches divided by 16.
It comes out 12.9.
Yeah, that's way, I mean, that's what they're saying. Does that make sense with the number of supports that they're speccing? The attachments, they're saying 54. So how many, we've got 6 rows, 54. So that's 9. Yeah, so we're going basically 9 for each of these rails. That makes more sense. And it's 32. How many is it? 3211. So basically 33. So what is 3211 divided by 9? Going to be about 38 inches,
That comes out 43.
43. So basically
did the math.
every third rafter is what that sounds like. So 48 inch. So that makes more sense. I guess I just am, the part that's unclear here is what this maximum span is meaning to us.
Well, I could tell you when I did mine, I spec'd out 48 inches every third rafter.
Yeah,
And so my guys who've done 100 installs go up there and they're putting it every 4 rafters. They don't even talk to me and they put it on there.
yeah,
And then I looked at it and said, something's not right there. And he said, no, this is what we always do. So I went back to Iron Ridge and they said, yeah, that's the maximum you can go with that XR100 rails. You can do every 4 rafters.
yeah.
So I remember that part of it. This is sort of confusing to me, what they're doing here.
Well, it looks like this is just kind of giving us a span limit. It says each XR maximum. So yeah, this is why it's a little confusing, because it's saying that's the maximum span, but they're speccing it out to basically be every third rafter. Because you've got, but they should somewhere tell you what the span is, although it's going to be slightly different, because if I let me go into the whiteboard here, because part of the issue that we're running into is, let's say we've got our six rafters, but I'll only draw 2, and this is going to be about 33 feet in length, and they've decided that we have 9 supports. Well, if your rafters are every 16 inches here between them, if I were to put a support here and then skip and then come up here and so on, so that by the time I've got to the end, I've got 4, 5, 6, 7, all right. So between each of these supports, it's going to be 3 times 16, right?
48.
48 inches.
Yeah. But I went with 64 inches on that install, and I went back to them, and they told me that was the maximum I can go with that.
Yeah, well, actually, but what I was going to get to is here, this is the cantilever space,
Right.
and that's going to be whatever it happens to be. I guess we could take our 48 inches times, how many of
8.
these? 6
8.
or 8? Yeah.
Yep.
So that's going to be 64, 32, 384 inches. And of course, because we're in such a weird world, that's going to be 32 feet exactly, is it?
Yes, sir.
All right. And our span was what, 3211?
Yeah.
So basically the cantilever is only going to be, it's going to be like 5.5 inches, ideally on each side. All right. Does that make sense?
That's good.
Yeah. Yeah.
Right.
Now, what the design thing is saying is that you could have gone, so our span is going to be 48 inches, but the maximum you could go is 7'3". So when you were at 68 inches, Bob, you were still under that 7'3". So that's the theoretical maximum. And the theoretical cantilever here is 2'11", but we're at 5.5 inches. So we're fine. We're within their specs.
But I have to tell you, those specs were not the specs that I used last October. It was a maximum of 4 rafters, 64 inches. Was the
64.
maximum.
Yeah, now they're telling you you could literally go a little bit further than that. I wouldn't though. I don't know why you would. You're just saving a little bit of support. I guess the issue would be if you're on 3-foot centers or something like that, you know, on your rafters, then you could go every other instead of every rafter. But really, I would rather spend the extra money. So then after you've designed it, they'll generate a bill of materials and it'll give you the retail price. So that particular purchase is going to cost us about $2,500 and it's going to weigh about 215 pounds. Now that's the full retail price. Do you remember, Bob, if this gave you a diagram?
Yes, it did. Not only did it give a diagram, but they sent all the information to CDE Green Tech, my distributor. They didn't even ask. They asked me who the distributor was. So I called up my guy. He says, "Yeah, I got it from Iron Ridge."
Oh, yeah?
So he already had it on the bill of material and costed and everything.
Did they give you a discount?
Oh yeah, they did.
Yeah.
The first guy did not, and then I asked for another guy, and then I got my discount.
Yeah, so this is showing you those things, and I guess you could provide this to your, they give you a service where you could buy the you know, permit ready diagrams, but this is
Right.
giving you kind of a thing here. It's showing 32 feet, cantilever of 6 inches, rails, 18 attachments. It's not really telling you the distance between. So, but we can figure that out just based on the numbers. Then it shows you some pictures of, you know, I'm sure those are just their stock. And so here's 1, 2, 3, 4, 5. I don't know why they don't show it the way, that's just your grounding. You'd think they'd build it out based on the number of panels you spec'd. But this is kind of good for a free service. So anybody have any questions on the Iron Ridge? They do have them for ballasted systems. They have them for ground mounted systems. The nice thing with the ground mounted systems is it will even give you the information about how many square feet of concrete you're going to need, or square yards of concrete you're going to need for the holes. It'll tell you the spacing between, that kind of thing.
Yeah.
And I'm familiar with the Iron Ridge system, but I'm not that familiar with other systems, but I do know they exist. So if you wanted to use a different racking system, they pretty much all have those tools that you can use out there.
Now, Iron Ridge, the one I put up, was a complicated footing system. You had to first put in your drivers into your brackets, and then you put this other piece on top of it and twisted it on, and then you had to hook it up to your rails. And I said, what are they doing? Why don't they just use an L bracket? So during the year, they came out with their new, cheaper system, which is just an L bracket.
Yeah, yeah. Yeah, I've used both of their systems there, the ones that you twist on. I mean, those ones that you twist on are attractive, you know, they're clean, but who sees the bracket on the underside of your solar array, you know? Plus they were a little bit more expensive, I think, as well. I think people don't really realize, though, you're using a bolt, you know, what, 6, 8 inches long, a lag bolt to lag those things into the rafters. So it's pretty heavy duty.
Yeah.
All right, so that was the
And
one.
by the
Yeah.
way, those lag bolts have to be torqued in.
Yes. Yeah, they have a torque specification that they're given. And I mean, literally all of the little units have their own torque specs.
Right.
What you'll
Exactly.
find on a lot of them is it's kind of like if it's snug, that's basically what they're torquing to. You know, they give you an exact number, but you can kind of sort of estimate it.
There was two torque specs. My guys had two electric drivers set to a setting, and when they put it in, they used one driver that was set, and you heard it ratchet, and then for the other ones, they used another one, and you heard it ratchet. So they had a preset
Yeah.
at an approximate value. I felt good about that.
Yep. And they have the torque like the one that's kind of critical that you can't really use an automated ratchet is when you're attaching the panels to the rails. Because if you ratchet it down too high, you're gonna, crack the panel or break it. So, one of this, I think the industry's not real good at torquing things to the proper value. Especially the do-it-yourselfers. They don't usually bring out a torque wrench and make sure that their torque specs are up to, they just kind of snug it down and that's good enough. And in most cases, it's going to be good enough. But to legitimately meet the warranty specifications, you're supposed to torque to their torque specifications. And then they also have those little marker gels that you can mark the bolts. So once you've torqued it down properly, you take the gel and you run a line from the bolt to the underlying so that you can see visually if the bolt is loosened at all from its original point. So it's just a straight line that's on the head of the bolt and on the thing next to it. And if it loosens, you can see that line has become disconnected. So that's something to look to on a annual evaluation. When you every year go and see if things are working.
Also, the material used for those bolts and stuff is non-metallic stainless steel, not to be confused with the other, which is metallic. They have two grades of stainless steel. Is it 601 is the one that I'm thinking of?
Yeah, I know what you mean.
Right.
I don't think it's non-metallic, it's non-galvanic. It's so that it
That's
will.
what I meant, yes.
Yeah. And that's basically like the O positive metals, because you don't want dissimilar metals touching each other.
Right.
Because then you'll get galvanic corrosion. And the metals will literally disintegrate over time.
They will.
Yeah. I had a situation, I was putting copper roofing on and I used galvanized nails. And like 2 years later, I came back and the nails had completely dissolved into dust, because they were the wrong metal type. So you could have used non-galvanic stainless steel, or better would be to use copper nails to attach that. So one of the issues we run into a lot in solar is if the bare copper wire for your grounding system, if that touches the aluminum casing of the solar panel, so as you're running it, it just happens to be, on it, laying on it, touching it, it will literally melt a groove into the aluminum and it will dissolve the copper. So, that can destroy your grounding system. So you do not want those metals touching each other. You either would insulate it, with some sort of rubber if it has the risk of touching that, or just make sure those, especially the grounding wire, those number 6 grounding wires are pretty stiff. You can just make sure it's not touching, just bend it out away from it and just make sure it's not touching. And speaking of things not working, let me take a look here. I wanted to check my solar array. This is my solar array. And as you'll notice yesterday, or this is today, this is my production. So I'm going to slow it down, but you can see as we start the day, right, we start to see that this area hit first. This one gets a little bit of shade early in the morning. But notice these are 250 watt inverters, and these are 215s. So these guys are maxing pretty much already. You can see it's plateaued here at its maximum production. But look at this little panel over here. I'm getting an indication that one of my inverters is not working. So I wanted to check that today because I did get a warning yesterday, an email telling me that one of my inverters was not responding. So in here, it's telling me system normal. These guys are all normal. And this guy, microinverter not reporting. So I've had 2 days of zero production from that guy. So I'm gonna have to go out. I was hoping it would reset itself this morning and that everything would be fine. But clearly there is a problem with this particular inverter. Not quite sure what's going on, whether it's a wire that somehow has come disconnected, which is possible because the goats are out there. Who knows? It's one of the ones that's low. So they might have just reached up and chomped a wire or something.
What
or it-
microinverter are you using?
Yeah, these are end phase.
But what?
Oh,
Not the
yeah.
IQ7, but
Yeah, no, these are the ones for this part, and I'll just give you a, just to show you the difference in production. What I've got over here are the M250s, and these 5 columns are the M250s, and they are on 300 watt panels. So you can see they're producing right up to their maximum. In fact, some of them are producing 251.
Mhm.
These guys are the 215s, the M215s. They're an older generation of microinverter, and they're on 250 watt panels. So I was able to buy these 215s. The reason I installed them is I got them for $29 a piece because they were discontinued, you know, but they work just fine, except obviously this guy just stopped working. One interesting thing about the microinverters though, is I bought them, they're new, they were new. I got them remaindered from, I think I got them from Renview, if any of you guys have worked with Renview. And basically because they were no longer California Rule 21 compliant, and much of their customer base, you know, is in California or states that require that you have the smart inverters. So they were basically just dumping off their inventory. And I was able to buy them for almost nothing. Well, our particular region doesn't require smart inverters. So we were fine there. So I got them real cheap. But one thing that I found is when I did receive them, the warranty, the 25-year warranty started on the date of manufacture, not on the date that I bought them. And they were already like 6 years old. So, so that was kind of interesting. I never really considered that until I actually saw it, that it was, you know, as soon as they're made, the clock starts ticking on that warranty.
Well,
do you have any? Go ahead.
End-phase warranty is weird in itself, that as far as the proof you have to go through that it's their problem is huge to start with before they recognize that they have a responsibility. And second, as far as covering the labor costs to repair that out there, Their warranties are like for only like 2 years maximum, I think. On
Yeah.
the portion.
Yeah, my understanding is obviously if this inverter has gone bad, then I will have to somehow, convince them that it's bad. I don't know if they can simply test it through this online monitoring system or not. I guess I'll find out because I've never had one go bad here before. And then, I'm going to have to reinstall it. Well, it's not a big deal. It's a ground mounted system. So I really literally just disconnect it, unbolt it, stick a new one up there and bolt it and connect it back in. So it's a 5-minute job because it's just really accessible. But yeah, if this were one of your jobs out in the field, you'd have to eat the installation costs because they're not going to cover that. And it'll be curious. I guess it'll be kind of interesting to see how that works. One thing, I guess, since I've got this up, you can see some interesting data here online. It's telling me that as of today, so far today, I've generated about 24 kilowatt hours of production. The average home uses about 30 per day. So this is showing month to date. So in the 2 days, not too bad this month. Lifetime, 38 megawatt hours. Okay, the reason I want to show that is because had the RECs remained at $200 a REC, at the time that I installed them, that's what they were selling for. But then Ohio's legislature stepped in like literally the week I installed the system and destroyed the REC market. But they were selling $200 a REC. Well, this is 38 so far. So 38 times 200. So we would be generating what, $7,600 in RECs to date.
So what's the rate now for Rex?
In Ohio, it's about $12.
Ooh.
Yeah, and it costs
Big
you
drop.
about $100 to file per year. So it really, I've never filed for the RECs because it's just not worth it in Ohio. Now, in some other locations, like in Washington, D.C., it's like $400 a REC right now. So some places have good RECs still, but not Ohio. And most states don't have RECs. It's only, what did we figure last time, Bob? Like 6 or 8 states
Not
have
even
RECs.
that today. Once Illinois, I think we're down to 5 now.
Yeah, Pennsylvania had fairly good RECs, if I remember, maybe like 20 something. Washington, D.C. was the best. Maryland, I think, has some. So they're mostly up in the Northeast anymore. Most of the country has gotten out of the REC business. So that's really more for commercial systems than residential. But $7,600 would have been nothing to sneeze at, considering the total cost of this system is somewhere in the range of $17,000. So that would be the cost. So to recover $7,000 in some of that would have been significant. To show you the difference in prices, this section here, this half was installed in 2014, and it cost $12,000. This half was installed in 2019, and it cost $4,500. So the cost was a little more than a third, about 40%, to do exactly the same size. And actually it's a little bit worse than that because the panels, the 300 watt panels, were the new ones I bought. And what I did is I took the new panels, I took the old panels off of this array and moved them over here because they were 250s. Because what I had was 250 microinverters and 250 panels. Because when I first installed, that was basically what we were told to do. Match the level of the panel with the inverter. But in the intervening years, we started seeing that there was a load to inverter load ratio for clipping. And so we wanted that load to inverter ratio at about 1.2. So the better match would have been to use the 300 watt panels with the 250s, and then to take the 250s and work those with the 215s that I just bought. So that's what I ended up doing. So I moved all the panels out of here and moved them over here, because I found that was easier than trying to take all the inverters off and move everything. I just left the inverters where they were. And what I found was interesting is when I moved the panels, I went ahead and washed them with like detergent, dishwashing detergent, and they were filthy. You know, they looked clean, but they were really, really dirty. And that surprised me, because all the literature that I've seen basically says that rain will take care of it. So I assume I was losing a fair amount of production, because there was, it wasn't dust. It was like a black, you know, accumulated air pollution that was on the panel. And of course, we don't live in an area that's highly polluted. So who knows what that was. It could just be that regardless on this planet, wherever you are, you're going to get some fallout. Or maybe it was accumulated pollen, you know, from trees sticking in there. I don't know. But I guess it just says you probably should clean your panels every couple of years.
Do you have any comments about the latest in-phase microinverter? I believe it's the IQ7.
I think they've got a 7 Plus out there.
That's what I used. That's what I used.
Yeah, well, Bob, you probably, I've installed, I think I installed the IQ7s, not the i7 Plus. I didn't have any problems with them. Did you run into anything?
Well, the main reason is because I kept on, I went up to like a 380 watt panels.
Yeah.
And when you start doing your arrays and stuff like that, you start outdistancing the specifications for, so they came up with, and they're even coming up with larger ones now to take more. So it's basically a same thing, but higher wattage outputs and stuff like that.
Yeah, and any of their I series, those basically is an indication they comply with the smart inverter specs. You know, when California Rule 21 came out, they came out with rules that said, okay, when you hook up an inverter, we want you to be able to condition the power on the grid to a certain extent, what they referred to as smart inverters. And a lot of locations have required smart inverters. So pretty much every new inverter you buy is going to meet. And, you know, if you remember, the inverters have to be manufactured to UL 1741 specifications, but the new spec is UL 1741 SA, which is the supplemental addendum, which deals with smart inverters. So if you're in an area that requires smart inverters, you've got to use the I series. You know, if you're putting in a new system, all your other ones are going to be grandfathered in if they're already installed. But new installs, you'd have to use the i6, the i7, the i7 Plus. I'm sure they're going to come out with an i8 here pretty soon, no doubt, because panels just keep getting bigger.
What is you say they condition the sine wave out of it somehow to, not per feedback from the power company but what, does anybody know the nature of that?
I know a little bit about it. Some of the things that they do, one of them that's sort of quite easy to understand why they'd want to do this, is the way inverters were set up is they operate within a range of grid voltage. So for instance, the grid is supposed to operate at plus or minus 6% off of 240, so coming into your residential home, it's going to be 240 volts plus or minus 6%. Well, the inverter might be set. I don't know that it's exactly that, but let's say it is. So if the voltage falls outside of that range, the inverter is designed to shut off. And it's designed to shut off the second, the millisecond it's outside that range. And then they're all designed to wait for 5 minutes and 5 minutes exactly, and then turn back on, 5 minutes after the grid signal has been reestablished. Well, couple of things. One is, what if you just got a little flicker, like half a second flicker on the grid? Was it really necessary for your inverter to shut down? Well, it was either all or nothing before, but these new inverters have enough capacity within them. They're smart enough to realize, okay, is this really a grid outage or is it a flicker? So that's one thing that they do. The other thing that they do is that 5 minute, let's wait for the grid signal to be reestablished. Well, what was happening in California, where there are a lot of these installs out there, let's say you've got 100,000 of these homes with microinverters, or even any inverter. The grid goes down, it reestablishes itself, and 5 minutes later, 100,000 homes all at the same moment come online, which draws down, it's like water pressure turning on all the spigots all at the same time. So now the voltage of the grid has dropped, and it drops below the plus or minus 6 range, and the grid crashes again because all of these things turned on at exactly the same time. So then the grid reestablishes itself, and then 5 minutes later, the grid crashes again. And they were getting these cascading crashes because all these microinverters were turning on at the same time. So now what the inverter does is it says, okay, I'm not going to come back online until the grid is ready to handle me coming back on. So it monitors the grid, and it's no longer a fixed period of time. It's now, are you ready for an additional load? Yes or no? Is there enough capacity out there? So there's soft start kind of situation there. Then there is also some conditioning of the waveform, like hertz. If it comes in at 59.9, should it go back out at 59.9, or shouldn't it help condition the power?
It's got to match the hertz. It's got to match the hertz.
Yeah, but if it can condition the power coming in and going out, I guess the idea was, if we've got all of these inverters out there connected up to the grid and the grid power is flowing through them, can we use these like a distributed power conditioning system, to clean up the power as it flows through these units? And that's part of what they're looking at as well. So that's the theory. Basically, they just regulated the customer to buy the equipment to clean up their grid. So those are some of the functionalities that are out there in the smart inverter world. Yeah, Bob.
Two things. As an installer and losing the REX program here in Illinois, all of a sudden my cost becomes very important to my profits. Maybe in a future time you can sort of address how to cost reduce systems, because what I'm paying for a system, and I'm doing a Cadillac system right now, is from a market standpoint is taking me out of the market. So I'd be very interested in hearing some ideas on cost from all you guys. And that was it on that.
Okay, yeah, we're going to run out of time here, but yeah, let me make a note to next time we'll address cost saving issues, cost ideas, because some of the things that just came to mind, I know some of the larger installers can buy in volume through cooperative purchasing agreements, to get the price of their product down, sort of like how a large wholesale or grocery store chain can buy their product cheaper than the mom and pop corner store, and get a significant cost advantage. In fact, I used to work in a carryout when I was in college, and it would drive me nuts because like Pepsi would be on sale at the Kroger store cheaper than what I paid wholesale in the store to buy it and resell it. And you go, really? How is that working? So those are some of the issues. Or you can do like Donald Trump. His success is just simply don't pay any of your vendors. So there's an item. So
I've tried that. It doesn't work.
not long term. Well, it seemed to work for him. So,
By the way, did you ever get hooked up with Aurora?
I didn't, but I found another system that I'm going to use because I was hoping to incorporate it in the level 2 curriculum. So I needed to have free access. And I found one that gives me free access.
What's that?
I don't remember the name of it offhand. I'll have to look at that. But you can do up to 5 systems for free each month. So I figured as a training tool, that would be an ideal situation because the students only need to do 1 or 2. So they'll get experience into it.
No, I think I know which one you're talking about, and I've used it, but it's not as anywhere near as powerful as Aurora.
That's fine. Yeah, that's fine too, because it's just an introduction to online design programming. So I just wanted them to get a sense of how these systems work, what they do, and I know Aurora is a good system but it's also relatively pricey. And sometimes if you give somebody a Cadillac version, it overwhelms them when they're just trying to understand, the very basics of how these things work. So I think this will work out fine. Yeah, Bill.
Is the course offering, and correct me if I'm wrong, at Blue Rock Station, that is on your website?
Which one? The wind class?
Yeah, where's the listing of the classes that you
They are on the website, but what we've done pretty much is suspend them, any face-to-face because until COVID's over. The wind class, normally I would be advertising it, but we offer that through Zane State, and then I'll take outside participants as well. But this semester, the one for next week, it's really weird because normally I'll only have about 7 or maybe 8 students through Zane State, and I can then take 4 or 5 from outside. This time I've got 19 students signed up from Zane State for the wind class. And so basically I just took it offline because I can't handle 19 students. I don't know how we're going to do the labs. So I just can't take anybody from the outside.
Interesting.
This particular offering. So
Oh, I do remember when you were handling the labs in my class, and it was crazy. It was totally crazy.
yeah.
Everybody coming up to you at the same time.
Yeah. Well, that part I don't mind, but the issue is I want them to have actual hands-on experience. And if you've got 19 students trying to work on, 2 labs simultaneously, it's just not going to work.
Yeah.
So that's going to be a little bit frustrating for me. So I'm afraid I'm going to have to come up with labs that are more research-based rather than turning screws, for the wind class, because we don't have the physical room here for that. Because I also have to deal with social distancing issues. So how do you keep the students 6 feet apart when they're working in groups of 6, all on one piece of equipment? So anyway, next week is going to be a bit of a challenge. All right. Anything from you there, Tim, in Columbus? You're muted still, Tim. You're still muted. There you go.
Copy.
Yep.
I'll have to get back to you. This is actually the Iron Ridge is a pretty interesting little program. It's an engineering program, right?
Yeah, it basically pre-engineers and then gives you a listing of bill of materials. So
Okay, because that's sort of my holdup right now is finding an engineer here for Upper
It-
Arlington.
if you want to use Iron Ridge, which I would recommend for your ground-mounted array,
Right.
you don't need an engineer for that. You can just use their system. And in fact, Iron Ridge, the drawings that they'll send you are pre-stamped by professional engineers. And if your building department has a concern about it, they will go on and speak to them directly. That's part of their service they offer. They'll put the engineer on the phone with your local building department.
Okay. Well, I need to go into that immediately, and I might need a little bit of assistance from you, Jay, for that.
Yeah, no problem. Yeah,
Okay,
we
I'll-
can walk through it and get it designed because I'm very familiar with that ground mounted system. It's quite good, quite easy, super easy to do.
Okay.
All right.
All right.
Okay. Anybody else have anything before we call it a day?
This is a good session.
Yeah. Yeah. These have been working out. I think, they're helpful to me. And plus I've been able to post them online. We record them. And it's amazing. We get, a half dozen or so people on, but then online, maybe 20, 30 people view it as a video. So,
Yeah, good.
So it has some value.
Is that on your website?
Yeah, it's on our website and it's also on YouTube. If you just did a Solar Noon Tuesday search, you'll find it. So it's on the Blue Rock Station channel. So,
Okay.
all right. See you guys later. Bye-bye.
All right.